Now coming to metallurgy, that is the chapter in which we are going to study about the extraction of the metals, about the properties of the metals, about the alloys and so many other things. So there are altogether 118 elements known to us at present. In the periodic table, if you see, there are 118 places are there. Of course, all the elements we do not know what you can say their properties. So about 80% of the known elements are metals. Now in ancient times, people knew only 8 metals: gold, silver, copper, tin, lead, mercury, which was called as quicksilver, and antimony. But later on, what you can say, when Mendeleev prepared the periodic table, altogether 63 elements was known to him. Out of that, nearly 50 were the metals. And today about 90 metals are known to us. Today 90 metals are known to us. So metals are the elements except hydrogen which forms positive ions by losing electrons, you know that. Alright, it forms positive ions by losing electrons. For example, sodium is a metal. It forms positive ion sodium ion Na plus by losing one electron. Alright, these atoms, they have large atomic size. And why they lose electrons? Because they have low ionization energy. Alright, these elements, these atoms, they have the large atomic size, and the question is, I said you just now to you that why it loses electrons, why it forms a cation. Alright, why it forms a positive ion? Because it has got low ionization energy. Due to low ionization energy, it loses electrons readily and forms cations. Alright, so metals have low ionization energy, compared to which non-metals are the elements which forms negative ion by gaining electrons because they have got high electron affinity. So metals and non-metals have certain characteristic properties which we have already studied. Out of that, reactive metals are sodium, potassium, calcium, magnesium and aluminum. Now let me tell you, these reactive metals could not be extracted until the 19th century. Alright, because at that time electricity was not known to us. Alright, electricity was it was not available to us. This is due to the fact that these ores are very stable and cannot be reduced by coke. As I said you, it cannot be reduced by coke, only they can be extracted with the help of electrolysis by the availability of electric power. And at that time electric power was not available to us, electricity was not available to us, so the electrolysis were not known to us. So these elements was very difficult to what you can say extract, because they are highly stable, we can say that, these particular elements, and they cannot be reduced by coke. Remember it, coke acts as a reducing agent, we can say that. Now you know that when you move from left to right across a period, the atomic size decreases, ionization potential increases. That of course we know it, we have studied in periodic properties. The most important property is that of course you studied in periodic properties also, this particular properties which I am going to say you, but here it is very important because this chapter is related to that. What is that? Metallic character decreases when you move from left to right, and non-metallic character increases. Metallic character decreases when you move from left to right, and non-metallic character increases. Similarly, when you come down the group, that is atomic size increases, ionization potential decreases, metallic character increases, and non-metallic character decreases. Alright, so we are also having, between metals and non-metals, we are having metalloids which possess the properties of both metals as well as non-metals, so to say. Now coming to the properties of the two, what you can say, most important group in the periodic table, that is group 1 and group 2. Group 1 belongs to alkali metals and group 2 belongs to alkaline earth metals. We can also say, according to the old convention, it has 1A, group 1 as, and group 2 as 2A. But this is, let me tell you, old convention. The new convention is a natural number. Alright, so alkali metals is group 1 and alkaline earth metals is group 2. So alkali metals in group 1 we are having lithium, sodium, potassium, rubidium, cesium, francium, whereas in alkaline earth metals it is beryllium, magnesium, calcium, strontium, barium and radium. We can see it on the screen. Alkali metals, they possess 1 valence electrons, alkaline earth metals, they possess 2 valence electrons. Alright, so hydrogen, you know, it is placed in the alkali metals. Why? Because it has got one electrons in it, outer one electron in its valence shell, one valence electron also I can call it as. Alright, so however it is not an alkali metal because it does not possess the properties of the alkali metals. It is placed in the group of alkali metals, no doubt about it, group 1, but it is not an alkali metal. First of all, hydrogen is not a metal at all. Got it? It's not a metal at all. So how it will be an alkali metal? No question about it. And when you will see the properties of the alkali metals, it does not match with hydrogen, except that it has got one electron, one valence electron, just like alkali metals. Got it? Just like alkali metals. For that reason, we have kept in the group of alkali metals, we can say. They are highly reactive alkali metals, and alkaline earth metals, they are also reactive, but less reactive than what you can say alkali metals. They occur in the combined state because they are reactive, no? So they occur in the combined state in the nature, and they also occur in the combined state, this alkaline earth metals. These are the similarities, I should say. Compounds of sodium and potassium, they are the most abundant, where the compounds of magnesium and calcium is the most abundant in case of alkaline earth metals. Francium occurs in traces. Francium, it occurs in traces. Got it? And why? Because actually francium is a radioactive metal, francium. And here radium is what you can say is a rare element. Rare means it is again same thing, it is a radioactive element. Radium is also. Now nature, if you see the nature and bonding, then alkali metals, they are silvery white metals. They are soft in nature, can be cut with a knife, whereas alkaline earth metals is also silvery white metals, but they are harder than alkali metals. They are harder. You can see it on the screen. I have written it, everything. Now possess single that is valence electron, already we have discussed, and as a result, hence metallic bonding is not so strong in alkali metals, whereas here it possesses two valence electrons and metallic bond is stronger. For that reason it's hard, na? Slightly harder. That is alkaline earth metals is slightly harder for that reason, because it possesses two valence electrons, we can say that. Now if you see the density, then alkali metals have got low density, whereas alkaline earth metals have slightly higher density. Now it has got low melting point, but alkaline earth metal has got high melting point because density is more. It is also hard, so melting point is also more. Similarly, it has got low boiling point. Alkali metals and alkaline earth metals have got high boiling point. It gives characteristic color to the flame, you know that. It gives characteristics color, like sodium burns with a golden yellow color, potassium with a lilac flame, lithium with a pink flame, we can say that. Similarly, what you can say in alkaline earth metals also, it burns with a characteristic color, like calcium with a brick red flame, strontium with a pea green flame, barium also with a green flame, we can say that. But magnesium and beryllium, it does not give any characteristic color to the flame. Rather, it burns with a dazzling white light, you know that, magnesium. Now next is electropositive character, that is increases from lithium to cesium. It is strong electropositive. Alkali metals and alkaline earth metals are less electropositive than alkali, we can say that. And it increases from beryllium to radium. They are highly reactive. Alkali metals and alkaline earth metals are less reactive in nature. Most reactive of all metals, definitely. Which one? That is alkali metals. They are the most reactive of all metals, and they are the less reactive compared to alkali metals. And calcium, strontium and barium are very reactive. In alkaline earth metals, calcium, strontium and barium are barium are very reactive, we can say that. Now on exposure to moisture, it tarnishes. Which one? Alkali metals, like sodium, it tarnishes, potassium, it tarnishes. For that reason, it's kept in an inert atmosphere. In an inert solvent it is being kept, that is, it is kept under kerosene, calcium, that is sodium and potassium, because you know, it reacts with the moisture present in the air, sodium, potassium, and it catches fire. Got it? Except lithium, we can see that. So exception is very important, remember it. Whereas in alkaline earth metals, on exposure to moisture, it tarnishes slowly. Here it tarnishes very rapidly, but tarnishes slowly, except beryllium, and forms a layer of oxide on the surface. Like, see, the reason is given here, that metals, when react with oxygen, it forms metallic oxide, and further reacts with the moisture present in the air to form metallic hydroxide. Like sodium, it reacts with oxygen to form sodium oxide. Sodium oxide dissolves in the moisture which is present in the air to form sodium hydroxide. Barium bursts into flame on exposure to air. Alright, alkaline earth metals, they are less reactive. Out of that, barium is very reactive. It bursts into flame on exposure to the air. Now, alkali metals react with water, liberating hydrogen. Like we have seen it, that sodium and potassium, when they react with water, it bursts into flame. Why? Because hydrogen gas is released, which is a highly exothermic reaction. When sodium and potassium they react with water, it's a highly exothermic reaction. For that reason, it bursts into flame. And moreover, hydrogen gas is released, which helps to catch fire, rather I should say, because hydrogen is highly inflammable, you know that. Here also it reacts with water, liberating hydrogen in case of alkaline earth metal. Lithium reacts slowly. Sodium, potassium, it's highly vigorous, but lithium is less vigorous, so it reacts slowly in case of alkali metals. While in case of alkaline earth metals, beryllium has got no action over water. Sodium reacts quite quietly, that is Na reacts quietly, that is quietly means what you find is that vigorously, but it does not have explosive reaction like potassium, we can say that. It is vigorous, it catches fire. Got it. Now magnesium reacts with boiling water. Now next is potassium, rubidium, cesium, they react vigorously, as I said you. React vigorously and hydrogen gas is released. Similarly, calcium, strontium, barium also decompose water and hydrogen gas is released. Now with acids, the reaction is highly vigorous. We never try it also with acids, because with water you can see it's so vigorous. With acids we cannot imagine that how vigorous will be this alkali metals. Now alkaline earth metals reacts with acids but less vigorously compared to alkali metals. Why it is vigorous in case of alkali metals or alkaline earth metals? Because it displaces hydrogen. Like Na plus HCl, M plus 2HCl given, na? So we can take, instead of M we can take Na. Na plus HCl will give you NaCl plus hydrogen. Alright, NaCl plus hydrogen, we can say that. In case of alkaline, now this equation it must come in the what you can say, alkaline earth metals. This side it should come, and here also that is same thing. When alkaline earth metal reacts with sulfuric acid, it gives nothing but sulfate is being formed, a salt is formed, and hydrogen gas is released, so to say. We can say that. Now next is if you see metals, there are certain exceptions are there. Now this is very important, this chart which you can see in front of you in the screen. The exception comes in the exams. Like metals, generally they are solid at room temperature, except mercury, gallium, they are liquids. Got it. In case of non-metals, they are liquids and gases or brittle solids. There is no exception for that. Metals, they are lustrous, they can be polished. We don't have any exception. Non-metals, they are non-lustrous, cannot be polished, except graphite and iodine, which is lustrous. Got it. And sublimes on heating. Non-metals generally do not sublime. Metals, they have got high boiling point, high melting point, except sodium, potassium, mercury. Non-metals, they have low melting and boiling point, except carbon and silicon. Metals, they have got high density like sodium, potassium, calcium. Non-metals, they have low density, except diamond, that is carbon. Metals can be drawn into wires, that is ductile, except zinc and mercury. Non-metals, they are non-ductile, example carbon fiber. Carbon fiber is it is ductile, we can say that. Malleable, metals are malleable except zinc beyond certain temperature. Non-metals are not malleable, again same thing, carbon fiber is malleable as well as ductile, that's an exception. Next is they are good conductors of electricity. Metals are exception, tungsten and aluminium wire. And non-metals, they are non-conductor of electricity except graphite, which is an allotrope of carbon. You know, graphite, they are good conductor of electricity. Now the metals are good conductor of heat, we don't have any exception. Non-metals, they are poor conductor of heat, also no exception. Now metals have high tensile strength, that is ability to withstand strain. Strain means what? Force, large force which it can withstand, except zinc and mercury. And non-metals, they have low tensile strength except carbon fiber. Carbon fiber cannot withstand a large force, we can say that. Can withstand a large force, I'm very sorry. Carbon fiber can withstand a large force. Non-metals cannot withstand a large force. It has got a very low tensile strength. Got it. Of course, non-metals are gases and liquids. They are not at all. The question of tenacity is going to come in case of non-metals. No question of. Except carbon fiber, which is tensile in nature. They are hard solids, what you can say, metals, except sodium, potassium, mercury and lead. You must be knowing it, that sodium, potassium can be cut with a knife. Alright, even lead is also soft, mercury is a liquid. Non-metals, they are soft solid except diamond, that is diamond, we can say carbon. Metals are sonorous because on striking with each other they give a sound, except sodium, potassium. Non-metals, they are not sonorous. We don't have any exception. Metals, they are insoluble in water or solvent, no exception. Non-metals, they are soluble in water or solvents, again no exception. Same thing, occurrence of chemical change and dissolution of liquid, no exception. No occurrence of chemical change or dissolution in liquid in case of non-metals. Metals forms alloys. Non-metals do not form alloys except carbon, that is nothing but it forms stainless steel which you are using in your house. Metals have got 1, 2, 3 valence electrons. Non-metals have got 4, 5, 6 as valence electrons. Hence they are polyatomic except inert gases. Metals, they lose electrons easily and they form cations. Non-metals, they gain electron easily and they form anions. Metals are electropositive because they lose electrons. They form electropositive, they form cations. Non-metals, they are electronegative because they gain electrons, they form anions. That is, they are discharged at cathode. Metals, during electrolysis, they are discharged at cathode. They accept electrons and they discharge at cathode, we can say that. And that is, non-metals, they lose electrons and they discharge at anode. They form neutral atom and they discharge at anode, we can say that. Now, metals, they act as a reducing agent. Metals, they are strong reducing agent because they donate electron during chemical reactions. Non-metals, they accept electron during chemical reaction and hence acts as an oxidizing agent. Remember that reducing agent reduces others but itself oxidizes. It itself oxidizes. Oxidizing agent oxidizes others but itself get reduced. For that reason I have said in oxidizing agent, non-metals are oxidizing agent. They accept electrons because itself it gets reduced. Similarly, metals, they reduce others but itself it gets oxidized because itself it loses electrons. Clear now? Active metals react to dilute acids to yield hydrogen gas. What you can say, and non-metals, they do not react to dilute acid. Clear? So since it can transfer electrons, now active metals, they form at least one basic oxide. Soluble basic oxide are known as alkalis, which are soluble in water. And non-metals, they form acidic oxide or neutral oxide. Got it? Soluble acidic oxide dissolves in water forming an acidic solution. Like basic oxide dissolves in water to form a basic solution which is called as alkalis. But acidic oxide dissolves in water to form acids. Metallic oxides are electrovalent, like basic oxide K2Na2 and all these things. Amphoteric is also there. Amphoteric means which reacts both with acids as bases, like aluminum oxide, lead oxide, zinc oxide, stannous oxide also, tin we can say that. Non-metallic oxides are carbon dioxide, sulfur dioxide, this, and neutral oxide are carbon monoxide, nitric oxide, nitrous oxide, water, they are said to be as. Now, metals, they form electrovalent chlorides, that is sodium chloride, electrovalent, and they are soluble in water, these chlorides are. Non-metals, they form covalent chlorides, volatile liquids they are, PCl3 or solids like PCl5, got it? And they are insoluble in water. Their chlorides are insoluble in water, so to say. Now, next is, this is about your metals and non-metals, that is alkali metals and alkaline earth, that is non-metals, alkaline earth metals. We studied about it, and the metals and non-metals we studied. The first we studied about alkali metals and alkaline earth metals, and after that we studied about metals and non-metals. Now, the next is we will come to, that is what you can say is that transition metals, we can say that. Transition. Now, they have got high melting and boiling point because transition metals of belonging to group 3 to 12, they are called why it is transition? Because their properties lies in between highly reactive metals and highly reactive non-metals. If you see on the left, we are having group 1, group 2 highly reactive metals. On the right, we are having group 13 to 18, which are the highly reactive non-metals. So then hence they are said to be as transition because their properties lies in between, we can say. Now, I don't say it is a metalloids. No. Metalloids means which possess the properties of both metals and non-metals. And here I am saying in case of transition elements, their properties lies in between. There is a difference between that. Try to understand. High melting and boiling point, much higher than alkali and alkaline earth metals. They are hard, strong metals. Unlike the soft alkali metals, they have high densities. They are much reactive, less reactive than alkali metals and alkaline earth metals. They form colored compounds. Generally, you can see alkali and alkaline earth metals, they form white or colorless compounds. But they form generally colored compounds like copper sulfate, manganese dioxide, then we can say that cobalt, chloride or cobalt oxide. Got it? And then cobalt nitrate. All these are colored compounds. We can say that. So many we can come to it. Nickel sulfate, nickel chloride, then ferric oxide, ferrous sulfate, then ferrous chloride. We can say all these are colored compounds. They are the colored ions. We can say that. So they have got more than one ion. Definitely, they show variable valencies. Transition elements. They show variable valencies like Fe2 plus Fe3 plus variable. Cu plus Cu2 plus variable, Sn2 plus Sn4 plus variable. Got it? CO2 plus CO means cobalt, CO2 plus CO3 plus again variable. So they have got variable valencies. Most of the transition elements, they have got variable oxidation state. They generally form catalysts. They are catalytic properties. Got it? They are generally used as a catalyst. We can say that, like iron, we can say nickel, we can say platinum, we can say palladium, we can say. So they are used as a catalyst. They have got the catalytic properties, and they are good conductors of heat and electricity. The transition elements are, transition metals are. So now coming to, that is what you can say, the reactivity. You know that the arrangement of metals in a vertical column and the decreasing order of the reactivities are called reactivity series, which you have studied in the lower classes, like that is potassium, sodium, calcium, magnesium, this particular series, we can say that. Clear? You can remember the series. I've told you a poem also, like popular scientists can make a zoo in the low humid country more satisfactory. This is the poem used to remember the metal activity series. So according to that particular series, if you will find that the metals which are at the top of the series, like sodium, potassium and all, they react with cold water to form hydroxides and hydrogen gas is released. Just now I was discussing. Magnesium, if you come down, magnesium, aluminium, zinc, they react with steam to form oxides, or hot water, we can say that. They react with, iron reacts with steam and it is reversible, and this also reacts with steam or hot water to form, liberate hydrogen, which, that is magnesium, aluminium, zinc, we can say that. Lead reaction is very slow with water, it's very slow, we can say that. Copper, mercury, silver, gold, they have got no reaction with either cold water or hot water or steam. They don't liberate hydrogen, we can say that. So if a metal reacts with water, it will release hydrogen with a squeaky pop sound, that is the hydrogen gas is released. Most metal loses their shining appearance over a period of time, just now we discussed, because it becomes tarnished. It gets tarnished because it forms oxide, we can say that. Like sodium, it forms sodium oxide, potassium forms potassium oxide, we can say. Now metals have hydrogen in the reactivity series, reacts with acids to liberate hydrogen gas, but metals below, just now I told you, copper, mercury, silver, gold, they have got no reaction with water, steam, acids, they don't react with it. Got it? Even for that reason, silver, gold, platinum, they are called as noble metals, because they have got no reaction with air, nor with water, nor with bases, neither with bases, nor with acids. So hence for that reason they are called as the noble metals, we can say that. So as I was talking to you, that you have seen it here, that when you are coming down the series, initially the elements which are at the top of the series, they react with cold water to liberate hydrogen gas. Then after that, magnesium, aluminium, they react with hot water or steam. Iron reacts with steam, which is reversible. So what you find, when you are coming down the group, the reactivity decreases, because first we are reacting with cold water, then after that with steam or hot water. Got it? And below hydrogen, the elements which are there, the metals which are there, they have got no reaction at all with hot water, cold water, steam, what you can say, steam or air or acids, bases, nothing, because they will not liberate hydrogen, because they are placed below hydrogen in the metal activity series. Got it? They are placed below hydrogen. Clear? So what you find is that if you want to do an experiment, you can do it in your lab, that you take one, there is 5, let us say 5 or 6 test tubes, you take it. Let us say you have taken 5 test tubes. Okay? Now after that, what you do is that you just add acids in the 5 test tube, like HCl you add it to it. HCl in the 5 test tube, A, B, C, D, E. Now in the first test tube, you add magnesium ribbon. You will see immediately a big squeaky pop sound will be heard. Got it? Because hydrogen gas is released with an exothermic reaction. With aluminium, it will be, what you can find is that fairly less than that of magnesium. Means sound will be there, reaction will be there, but it will be not so faster as like of magnesium. So it proves the aluminium is less reactive than magnesium. Now with zinc, no sound is there, just little bit of gas is evolved with zinc. Alright, no squeaky sound is there, like pop, this sound, that is called a squeaky pop. in this way. So that sound you will not get in case of zinc. That means reaction is taking place, but it's very slow. That means zinc is less reactive than aluminium, which is less reactive than magnesium. Now with iron, if you add, you will find when you add iron to this, you will find that gas is evolved little bit of, we can say that, and slowly what you can say, the gas is evolved, we can say. Now if you add copper to HCl, suppose your test tube, you have taken HCl and you add copper to it, nothing will happen, nothing, no reaction at all, no gases is evolved, nothing is evolved. So in this way we have made this series, the metal activity series, we have made it accordingly for that particular reason, that metals we have seen it, which are highly reactive, they are kept at the top of the series, then less reactive still bottom, then still less reactive still bottom, and the elements or the metals which are not at all reactive, they do not displace hydrogen neither from acids, water, bases, air, nothing, so they are being kept below hydrogen in the metal activity series, we can say that. Clear? So in this way the metal activity series is being prepared accordingly. Now metals in the middle of the reactivity series like iron, lead and zinc cannot be obtained simply by heating of their ores. You will see it. After this we will start reduction process, we will start the extraction of metals. There you will see that simply by heating of this particular ore you cannot obtain iron. Like suppose if you take iron oxide, if you heat it, will you get iron and oxygen will be liberated? No. If you take zinc oxide and if you heat it in air, will you get zinc and oxygen will be liberated? No. So they has to be reduced. Alright, their oxides has to be reduced by using a reducing agent like carbon or carbon monoxide and hydrogen. Like zinc oxide reacts with carbon to form zinc and carbon monoxide. Ferric oxide reacts with carbon to form iron and carbon monoxide, and carbon dioxide gas is released in this way. So they are being reduced by reducing agents like carbon, carbon monoxide and hydrogen, we can say that. So this is about the basics of the first part of this particular chapter, that is your metallurgy, we can say that, where we discussed about the difference between metals, non-metals, alkali metals and alkaline earth metals, the similarities also, and we have seen the metal activity series, how it is being made and what are the properties of the metal activity series, everything we discussed here. Thank you.